Hello, let's continue our Sudoku adventure with Count the Entropy by Randall. So we have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have a single very long peach line in the grid. Do pay attention here how it crosses through here, then back up, and then crosses down. It doesn't like take a weird corner or anything. It's going straight through. But this is an entropic line. So what that means is if you take any three adjacent digits along a line, such as these three, that group of digits needs to have one low, one medium, and one high digit. A low being 1, 2, a medium being 3, 4, and high being 5, 6. So if this was a 2, for example, that means we can't put another 1 or 2 in this group of 3. And so we could do, say, a 5 here, and then we could do a 3 here. That would be one way to fulfill this group of 3. But keep in mind that we also have other groups of 3 on the line, like this group of 3, right? Or this group of 3, or this group of 3. It's every single overlapping group of 3. So this group of 3 would need to have one of each, for example. So that's how entropic lines work. We also have circles in the grid. These are counting circles. So a digit in a circle indicates how many circles contain that digit. So it only pertains to digits that appear in the circles, but say a 3 appears in a circle, say here, and we doot, then that means that exactly 3 circles in the grid have 3s in them. So maybe we could do something like this. And then none of these other circles would have a 3. They'd have to have other digits in them. And so if we say put a 2 in one of the circles, and we need one more 2, but then we can't have any more. So it's an exact count. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. So with entropic lines, I think a really good way to start is to color. So what do I mean by that? Well, I'm just going to use purple. Sorry, I just said purple when I placed green. I'm going to use green, purple, and orange, or I'll use blue. Green, purple, and blue. So what these represent is, I don't know which group green is, but it's going to consistently be the same group. So if green might be 1, 2, green might be 3, 4, or it might be 5, 6. We don't know, but it's going to be one of the groups. We'll call that group A. And then purple will be group B, and blue will be group C. So they're the 3 distinct groups. And we know that that these 3, because they're 3 adjacent along the line, have one of each group. Now we also know that there's one of each group here. But there's already a purple and a blue appearing, so we have to put a green here. And what you'll find is that causes a cycle. So now this group of 3 has blue and green, so it needs a purple. So we're always going to be going green, purple, blue, green, purple, blue, green, purple, blue, green, purple, blue, green. Oops, I didn't follow my own advice. So sorry, purple, blue. This is green, purple, blue, green, purple, blue, green, purple, blue. Now, the other thing we know is that there's 2 of each blue, 2 of each purple, and 2 of each green in every row, column, and box. So we can use that. For example, here we've got 2 blues and 2 purples. So these are green. Now we have 2 greens in this row. So we have a purple and a blue here. So if there is a purple up here, that's all the purples for the box. So this has to be blue. I guess we could just use the row for that. This is a purple and a blue. Let's see, where can we actually put colors? These have to be blues for the column. So we have 1 green, 1 purple here. 1 green, 1 purple here. 1 green, 1 purple here. Can we do any more coloring? Yes, over here we need 2 purples for this column. Okay, now we need a blue here. Does that help? Well, okay, so yeah, this box needs a green. That's an easy way to do it. This row needs a green as well. This box needs a purple. This column needs a green. This box needs a purple. This row needs a purple. This row needs a green. Now, hopefully, nope, not green. Blue. Hopefully I did that right. Let's just take a look. I'm looking at every box. Okay, boxes look good. Columns. I'm just looking for 2 of each color. Rows. I think I did it right. Okay. So now we're fully colored. So now we have to deal with the counting circles. So the counting circles are going to distinguish our digits here. I think it's interesting that we're seeing, for example, that there's 3 purples. Are there any, there's a significant number of blue circles. So maybe that's a good place to start. Because there are 1, 2, 3, 4, there are 5 blue circles those could just all be 5s or 6s. Okay, so one thing we do know is that that blue cannot be medium. Because imagine blue is medium. Then that would mean that there's 3s and 4s in our circles. But these are the only circles that can be 3, 4. There's only 5 of them. We can't have them all be 3 or all be 4, and 3 plus 4 is 7. Now I think we have the same issue with 1, 2. Because if they were all 1, 2, these are the only circles that can be 1, 2, because these other circles are differently colored. But we'd only be able to fill 3 of the circles before we ran out of the ability to place 1s and 2s. So this does have to be 5, 6. Now we don't, well, yeah, because they have to be 5, because if they were 6, there'd need to be a 6th blue circle, and there's not. So these are all 5. Perfect. Now, that leaves green and purple. Okay, yeah, perfect. Purple, there's 4 purple circles, and high is gone. Not that we could make them high, right? These have to be 4, because if they were from 1, 2, we'd only be able to have 3 circles, and if they were 3s, there'd be too many 3s. So they're all 4s. And they can't be 3 plus 4, which is 7. And then now these are from 1, 2. 2 of them are 2, and 1 of them's a 1. This is probably enough to finish. Let's see. Actually, how are we distinguishing 1s and 2s? One of these circles has to do it. Is there some reason? I bet we're gonna have to subcolor them. So let's just finish the rest of the puzzle. We should be able to finish each color individually, because they don't really affect each other at this point. So this is 6, this is 6, this is 6, this is 6, this is 5, this is 6, this is 6. We get our 5. Oops, sorry. The 3 is mid. We get our 3 here. 4 and 3. We get our 3, 4, and 3. We get our 4. Oops, 3 here. Now, the 1, 2s we're going to subcolor, which I think will help, because by subcoloring we'll find out which of these have to both be the same as each other. So I'm just gonna put a little gray slash on one of these types. So the gray slash is either a 1 or a 2, and the non-gray slash is the other one. So this is a gray slash. So we already know that these 2 are the same. Oh, I could have just seen that. These 2 have to be the same because of the way the box works. Okay, so these have to be the 2s, and then this is the 1, and that should let us finish this. Didn't have to color. I don't know why I didn't see that until I colored, but coloring can really reveal stuff like that to you. Cool. This was a really neat puzzle, Randall. I really enjoyed that. Always fun when you can do, like, it's almost 2 puzzles in one. You color, and then you deal with the digits. It's always fun. I hope you enjoyed this as well, and if you did, then why not leave a like, subscribe, and a kind comment below.